This conference will now be recorded.
Hi everyone, my name is Hao. I'm a hardware engineer at Facebook. Today, I'm very excited to present the video transcode accelerator in Facebook Datacenter with my colleague Jeremy and Bras. So I will give a quick introduction on why accelerators and the video stack at Facebook. In addition, I will introduce the hardware system. After my session, Jeremy will give you an overview of the validation to release to production session. And Bras will give you the introduction, the introduction for the exciting things happens on the industrial collaboration work. So let's look at the Facebook video workload. On the Facebook Watch, we have over 400 million monthly active users and 75 million plus daily active users. And if you look at the Facebook Live, we have the broadcast doubled year over year since 2016. So the video workload keep increasing sharply nowadays. If you look at what kind of the video transcode workload happens at Facebook in our data center, in short, like we take all the video tapes from the customers, end users, and decode them into the raw frames. Then we reshape it to different resolutions and codecs so that we save it in the data center and can send it to all the end users based on the handheld device and the network conditions they have. So during this process, there is a lot of computational power needed for the video workload, and currently like the CPU calculation power is not good enough to support that kind of increasing workload. So we introduce video stack at a Facebook data center. At the bottom, you see it's a hardware with accelerator ASICs and the modules. And on top of it, we redesign all the system software and the infra toolings to support this new type of the hardware in our DC. So video transcode software engineer can use this hardware to support the FFmpeg integration and the video codec library. The service team will use this library to support the apps like Facebook Watch and Facebook Live. Now let's take a closer look at the hardware system, how it looks like. The ASIC will be sitting on the single M.2 modules, and we will have 12 modules in the carrier card, which we call it the Glacier Point V2 card. Glacier Point V2 card will be plugged into the Yosemite V2 system. So the subunit of this system, we call it a sled. Each sled will have 2 CPU cards and 2 GPV2 extension cards and 1 shared NIC. So it's we call it a super node. So on the rack level, we will have 16 sleds plugged into the rack. Take a close look at the ASIC and the module. The module will be standard M.2 form factor, which is defined by PCIe 6, so we can leverage the ecosystem or existed ecosystem without any problem. You also see the LPDDR4X chips on that with the power circuits. So on the edge fingers, the pin definition is fully compatible with the M.2 standard definition. We redefine some of the NC pins to add more debug interface there to make this ASIC more robust in the data center environment. On top of the system block diagram, this is what I explained as a super node. The twinlet card will be the CPU card, and the GPV2 card will be the carrier card. In between the CPU and the carrier card, there are 24 PCIe Gen 3 lanes, and we use the PCIe switch on the GPV2 to fan out those 24 lanes to 48 lanes so that we can support 12 M.2 accelerators. Each of them is by 4 PCIe lanes. On the rack level, as what I mentioned before, it has the 16 YV2 sleds, and in the end, it's 32 hosts for the rack. This number is bounded by the 12.6 kilowatt rack power and failure domain consideration. So with I finished my introduction to the hardware introduction, and I will glad to introduce Jeremy to talk about the validation part.
Thank you, Hal, for the introduction. Hello, everyone. This is Jeremy from Facebook Release to Production team. So there's a long road after we have the new hardware designed within internal ecosystem and our industry partners, and eventually go to the data center integration. So roughly, we go through bring up, the validation, the integration part, and deployment at scale level. And we roughly partition to 3 phases during this process. The first one is we call engineering validation, which is we enable the ASIC, we plug them into the system and do a preliminary functional testing. So in this phase, we focus on a various of validations, including high-speed I/O characterization, for example, PCIe and LPDDR4 training. So we also test hardware like the PCB stack up, the SiPi design, and power sequencing and thermal behavior to make sure the design is within the expectation. We also spend lots of efforts to validate the preliminary video functional testing, make sure we can do basic transcoding tests. So after this phase, we should have a pretty decent hardware validation and system evaluation report to help us make a decision of, A, is there any silicon ECO needed? Is there a stepping required? B, in the board level, do we need to have a different board restraint? And lots of firmware and software change is involved, and high-speed I/O tuning is involved in this phase. So once the hardware is relatively in the stable phase, we move on to the next phase, which is we call development validation time. So in the DVT phase, how can you move on okay, thank you. So in the DVT timeframe, we scale the sample size from a couple of dozens in the benchtop to hundreds of samples in the full rack. And we focus on more rack level testing. For example, the manufacturing tests, the power stress, the network stress, and also the RAS related checks, the serviceability, reliability, and availability. So doing error injection and to see if there are any, the error handling mechanism is functional or not. And then in this phase, we also introduce the production shadow testing, which is basically to route a small pieces of video traffic pipeline from the current production pool into the new hardware and compare the behavior, functionality, stability, performance, and quality between the hardware solution versus existing software solution. So it can help us having the real data of what is the quality, what is the stability regression in the new design. And by end of this DVT phase, we should have the hardware skill lock. Most of the time, issue should be fully resolved or waived or disposed. And then we can move on to the infrastructure tooling, development, deployment, and even larger scale. And the third phase is we call production validation. So in this phase, we focus on many more racks compared to a single digits of rack, and we deploy to several of data centers infrastructure. So a lot more at scale level production testing. For example, the VOD, which is user uploads, and Facebook Live. So lots of DC integration efforts will happen. We need to ensure our DC techs can quickly integrate the number of racks into data center and conduct repair, remediation, and spare part management. Finally, the hardware analytics. So we need to have full picture of how the hardware in data center is performing, including monitoring and telemetry and performance counter. So building that infrastructure to monitor the at-scale hardware is a major focus in this area, in this phase. And by end of the PVT, we should be able to have the confidence to move into mass production and larger scale to the data center. So with all this validation part, I will hand over to sourcing team. Baras will talk about the partnership with industry. Thank you.
Yeah, thank you, Jeremy and Hal. When Facebook started working on video accelerators over 2 years ago, We found that the solutions out there were not really customized for hyperscale use cases. And so we wanted to approach it from the ground up in terms of both IP as well as form factor, as well as the type of integration that how discussed for fitting into server form factors. And today we're happy to bring on stage a surprise partner of ours, Broadcom, and Rakesh Agarwal from the marketing team to kind of talk about the collaboration they've had with Facebook as well as the product and what they plan to contribute to the community. So with that, Rakesh.
Thank you, Bharat. Thank you for the introduction. I am Rakesh Agarwal from marketing at Broadcom. As Bharat mentioned, Broadcom has been working with Facebook to develop a high-density real-time video transcoder ASIC. This video transcoder ASIC supports multiple codecs. It supports all the widely used codecs like H.264, H.265, BP9. It has a very high transcode throughput of 1 gigapixels per second. And this 1 gigapixel per second throughput can be subdivided into multiple streams, video streams of lower resolutions, all the way up to 4K resolution. And this throughput, this 1 gigapixel throughput is supported in the low M.2 power budget of 10 watts, which translates into 10 nanowatts per pixel for transcoding. Together with this high density and low power consumption, this hardware transcoder significantly reduces operating cost for the video processing in the hyperscale data centers. The drivers for this hardware transcoder ASIC sits underneath existing video applications like FFmpeg, and this enables seamless software integration with the existing video processing infrastructure in the data center and make the transition very painless.
Okay, this is great, Rakesh. I think it's pretty exciting. Obviously, we're at OCP, and so we would like to hear a little bit about how Broadcom is planning to contribute to the community.
Absolutely. Broadcom is enabling the broad adoption of video hardware accelerators by contributing both hardware components and the software components to the OCP and other open source forums. For hardware module, we are contributing the schematic, layout, PCB assembly files for the M.2 module that we have built along with Facebook. For software, we are contributing our host drivers, plugins to the FFmpeg, user space libraries, and utilities. And all of this submission we plan to complete by the middle of this year.
Okay, that's great, Rakesh. I think this is quite exciting for us, and this is kind of aligned with Facebook's philosophy of working with partners in defining leading edge projects, but then also making sure that it goes into the community for broad adoption. So we want to thank you for the partnership and look forward to your contributions to the community.
Thank you for the opportunity.
Thank you all. It's time for the Q&A.
So I think one of the questions was around, does it support AV1 encoding? We are not going into the details of the specific partner products and what they support, but that is something that you could follow up with the partner we discussed and get some additional details.
I see a question on the latency of transcode. Depends on the application. For this product, we support live and VOD. So if it's a video on demand, we focus on quality, and the latency can be higher. If it's a live transcoding, the latency is lower. So for the more details, you can refer to the detailed spec for the latency part.
Yeah, I will address the Fpga question. Yeah, we look at the Fpga before. In the end, the study shows like the ASIC has a good power, form factor, and density and I/O requirement we need. So that we do see like ASIC has a better solution than Fpga for our use case.
So the question in terms of transcoder IP being opened up, the contributions are primarily, as was shown in the slide, pertaining to the hardware form factor as well as the integration libraries that will be required to run the solution. So that is the focus and not the transcoder IP. But
well, I can take the rack configuration. So I see what else is in the rack. The illustration suggests it's more than just YV2 sleds. Yeah, so we do have switch and power units and also YV2 sleds. How maybe you can add more details? So there's a question, considering the longer runtime required for a video process, is localized backup power required? So I think maybe how you can chime in as well. So as based on what our current rack design, we do have backup power. So this is a common design across our full rack level design.
Yeah, basically it's a standard ORV2 rack configuration. We have the power toggle switch, and the rest of them will be the YV2 sled. The rack configuration is very similar as the Yosemite, as the ORV2 Yosemite V2 configuration.
There's a question, can you provide a ROM comparison of how much the video transcode solution will impact stream quality, the current software solution? How much better will video look on Facebook Watch and Live? So at a high level, we are evaluating the video quality. That's a good question. So we're evaluating video quality between hardware and software, and there are some internal evaluation data. Not sure at this point we can share, but this is an actively ongoing efforts as we're introducing the hardware solution. In terms of idea of improved user/customer experience, this ties back to what we talked during the presentation. In the NPI new product phase, we do production shadow testing. Basically, we're rerouting a portion of the actual production traffic into ASIC and compare with the current software solution. And this is, again, ongoing process.
Yep. There is a question on what else is in the rack, and the illustration suggests it's more than just YV2 sleds. I think Hao covered this. It is a combination of YV2 and Glacier Point. The combination of the two is what comprises the rack.
How do you support content overlay in video? So this is going back to the technical details for the how the hardware video transcode chip can support, and also the Broadcom software stack offering. So probably we can refer back to the design specification for this level of detail.
Yeah, to address the deployment question, Facebook's application will be targeted for the data center. Maybe you can check with, for other use cases, like we encourage you to connect with Rakesh and Broadcom to see, like based on different use case, like is there any other application case?
Paul, maybe you want to address the question as a backup time.
Where is the question? Which question?
The question is the 5 minutes of backup time sufficient?
Yeah, I need to check the context of this question.
Okay, so I can take this question from Raul Diaz. How to measure video quality and bitrate efficiency for your transcoder? So there are a couple of industry-wise quality measurement standard. For example, the SSIM, PSNR, and VMAF. So we've been adopting the common quality measurements methodology to evaluate the video quality for this transcoder chip.
Oh, okay. Yeah, let me address on this. The question is like, is the 5 minutes backup time for the ORV2 system, is that sufficient? So basically, like this one is related to the ORV2 system. Currently, like our design is compatible to the ORV2. Our design is compatible to the ORV2 and the Yosemite V2. We use the same configurations, and we think it's enough.
The question is, how do you measure the transcoding throughput for this FF? Is it bandwidth matched bottleneck by PCIe? Yeah, this is a very good question. I'm not sure at this point we can share the data or technical detail on the profiling and performance testing. We do measure the throughput, FPS and bit rates, and also we do monitor the PCIe traffic and network traffic during the characterization.
There is a question saying, how do you connect the transcoding into the machine learning system? So we encourage you to look at another like AI Accelerator presentations, which Facebook is giving at the same time, right? So basically, you can see like we use the same platform, same form factor. So in theory, like we can exchange the data between the machine learning system and the transcoding system to fulfill the future needs.
There's a question, where can I find the design specification document? Maybe Hao can chime in. So basically for the Broadcom part, Rakesh, who is Broadcom marketing team, he basically talked about the high level schedule when they will upstream the software, when they will open source. So you can refer to that part of the timeline. And I believe we do share the GPV2 and module spec as a OCP contribution. Is that right, Hao?
Correct. Yeah. So the as Jeremy mentioned, for the IC level, information you can check with Broadcom. For the platform, like the Glacier Point V2 card and the M.2 Accelerator module spec is on the OCP server group. Currently, it has not been finalized yet, but you can find it in their repository for the current version. So we try to finalize it shortly in this year. Yeah.
Is there a performance per watts number comparison showing how much better M.2 ASIC is comparing to traditional PCIe form factor GPU? It's a good question. So it depends on how you view and how you compare. So if you look at the M.2 form factor, it's definitely lower power compared to the GPU, but it's relatively focused application. So we mainly use the M.2 ASIC for video transcode. So we do see performance watt advantage using this M.2 ASIC for very particular workload.
I think we addressed all the questions, I believe, right?
Yeah, I think that's all the questions. Okay, so if there's no more questions, thank you very much. I'm glad to share this work with the community and hope to hear your feedbacks. And thank you for OCP for organizing that. Bye.
Yep. Thank you all.
Yeah, thank you.